Good afternoon. I'm Mr. Ish. Thank you for joining me. This can very well be a good motivational video. Consider it that, an inspirational or motivational video. I have a question over here. Area of a triangle equals half base times height. A simple area formula we learned very early on in life. The question here is why? You could answer this question perhaps in under a minute if you were to use integral calculus or calculus, but we cannot, because many of the viewers watching this video, or perhaps some of them, or maybe many of them, might know calculus and they can do it. Consider this to be a video geared towards those who have little to no calculus foundation. So in that instance, it's a difficult question to answer, but we will try to do this without doing calculus. And again, we're trying to inspire you here with regards to mathematics. How about we start like this? We have a specific x and y plane. We have a point over there 0 comma h, and I have a point here b comma 0. Why have I picked these? Well, that y-intercept 0 comma h, very well, the h can represent the height. The x-intercept b comma 0, the b can represent the base. When you connect this, you have generated a triangle. You have a b comma 0, 0 comma h, you have a certain height here, and you have a certain base over here. You have two dimensions. You know you've generated a triangle. Now within this triangle, if we were to supposedly, remember I'm not drawing anything here to scale or 100% accuracy. I'm just trying to do things in a clean manner. If I draw 1, 2, 3, and then 4 rectangles, you see each of those rectangles I've drawn, and we were to determine the area of these rectangles individually, you determine them, you add up all of these areas, then you should very well get to that formula, half base times height. So you're seeing what the format here is, or what the technique is. We're looking here at rectangles which have been squeezed into that triangle, and you determine the sum of these rectangles and you get to that formula because it'll add up to that. If you're looking here at this point, it's 0 comma 0, b comma 0, 0 comma h. If you're looking at this entire distance, you know we have a distance here of b, right? In terms of x-axis, we have a distance here of b. In terms of y-axis, we have a distance here of h. Each of these rectangles has a certain width, and each of these rectangles has a certain height or a length. Length, width, length, width, length, and width. And you know the area of a rectangle is always length times width. I'm just trying to help you here demonstrate the concept behind this, but we won't be doing everything individually. I'm just trying to show you how these are fitting into this scheme. If you consider this entire interval of b, you have an ending point b, you have a starting point 0, and you were to do b minus 0 and divide them by the number of rectangles. How many rectangles have I drawn? 4. I have a b over 4. This b over 4 represents a width of each of these rectangles. Think about it. I've taken the entire dimension b into which are squeezed 4 rectangles. Therefore, each rectangle must have a width of b over 4. Now let's talk about the height or the length. Let this be representing here the length of each rectangle. This here represents the width of each rectangle. If I were to take 0 comma h and b comma 0, and I were to generate a equation of a line y equals mx plus b, I can do that. First I need to find the slope. y2 minus y1, x2 minus x1, I have a minus h over b, but I already have a y-intercept. My equation here is y is equal to minus h over b x plus h. And that right there is an equation of a function f of x. F of x is equal to minus h over bx plus h. Now, that equation of the function very well is synonymous to some degree to your length. It represents the distance from this x-axis to anywhere on this line. That will be representing the length of each rectangle. Now what we should do is show you how a procedure develops. We're looking here at an interval, we're looking here at some sample point, and then we're looking here at a function with regards to how everything will feed in. Our sample point will feed into this function. What is this function? It's right over there for you. Right over here. What's my interval? Well, I have one interval here from 0 to this end of this rectangle, then from this to that, then that to that, that to that. And how can I determine this? Well, I know I'm going by quarters. I've split a certain interval into 4 rectangles, therefore I'm going by quarters. I'm going from 0 to 1 over 4. Except instead of saying 1 over 4, because everything here is in terms of b, I'm saying b over 4. Then my next interval is b over 4 to 2b over 4. 2b over 4, but I can say that as b over 2 because 2b over 4 is the same thing as b over 2, half, Remember, we're going here by quarters. My next one is b over 2 to 3b over 4. You're going from 0 to a quarter, quarter to a half, half to a 3/4, and 3/4 to a full. 3b over 4 to a 4b over 4, or you can just say b. And that right there is my 4 intervals. Each of these intervals represents the base of each of these rectangles. The sample point, I want to look at the middle points of each of these. Why? Because the middle of everything or anything you're examining always is a better estimation to use than the outlying or the extremes. Always go for the middles. When I'm looking at the middle of a 0 and a quarter, I get a b over 8. You can do this very easily on your calculator, and I'll show you. You just do 0 plus 1 over 4. And you divide that by 2, I get a 0.125. That's a 1 over 8. If you do a quarter and a half, you do add that on your calculator. Just do 1 over 4 plus 1 over 2 divided by 2. You'll get a 3b over 8, which is a 0.375. Do the same thing over here. This plus this divided by 2, you'll get a 5b over 8. And notice the trend. We're going here by 2's. If this is a 5b over 8, then this must be 7b over 8. We've gotten the middle value of this interval, middle value of this sub-interval, middle of this sub, and middle of this sub-interval. And we've gotten these. Now each of these values has to go right over here because these represent your x-axis values, which will go right here into your function. You have to plug them in individually, and to plug them in and cleanly, I will write them out here, then I'll erase it and I'll write it. Think about it. I have a minus hx over b, but x over here represents b over 8, and then I have a plus h. The b's will cancel out. I have a minus h over 8 plus h. You do a common denominator, I'll have a minus h plus 8h, and I'll have a 7h over 8. That's exactly what I'm getting with this first one, 7h over 8. It's nothing here that is not beyond a high school level here. 7h over 8, that's coming from here. Now in this one, I'll do the exact same thing. I have a minus h over b, x. X here is 3b over 8 plus h. These b's cancel out. I have a minus 3h over 8 plus h. See, minus 3h over 8 plus h. When I do a common denominator, I'll get here a 5h over 8. And very soon a pattern will develop. I'm getting a 5h over 8. It's a bit of a tongue twister involved over here with these h's and these 8's. But you're seeing everything is decreasing here by 2's. I'm going 7h over 8, 5h over 8. This next one must obviously be 3h over 8, and then this next one right here will be 1h over 8. I won't even bother writing the 1, it will be an h over 8. But you could have technically plugged these in places of these x's and you would find out exactly what I'm putting over there. So nothing over here is out of the ordinary or nothing that I'm making up. Now, we've got these values over here. Each of these values represents your length. But we know what the width of each rectangle is. Width of each rectangle is this. You can do this times this, which will give you the area of this rectangle. Then you can do this times the same width, it will give you the area of that rectangle. You can do this times that, it will give you the area of the third rectangle. And lastly, this times that, it will give you the area, and then you'll add all of those. Or you can do a shortcut formula, and that shortcut formula will be, you will just add all of these together and then you'll multiply them once with just a single b over 4, which is your width. Why not just add them up once? Because individually multiplying them like this, adding, multiplying, adding, multiplying, is no different than you adding all the lengths and multiplying them a single time with the width. Add these up. You have a 7h over 8. Everything here is the same in terms of denominator. All you have to do is just add these coefficients. Do 7 plus 5 plus 3 plus 1. I'm getting a 16h over 8. When I add all of these, I get a 16h over 8, which you know is a 2h. 8 goes in 16 two times. I have a 2h. That's my cumulative length of all of these 4 rectangles. I have a width over here. I have to multiply 2h with b over 4. And let's do that, and we'll do that right over here. 2h, which is your cumulative length of those 4 rectangles, times the width of each rectangle, which is a b over 4. That cancels out, and you have here an hb over 2, which is 1 over 2 base times height, and there it is. The area formula of a triangle. By you decomposing the triangle into 4 rectangles and getting the sums of each of these rectangles individually, adding them up, and that gives you that. It's called the decomposition technique because you decompose a larger figure into smaller shapes. You do their cumulative sums and you arrive at the total area or the area formula for whatever initial shape that you're looking at. The initial shape here being triangle. We just use 4 rectangles to do it. Now this right here is a very basic preliminary calculus technique, but I used no calculus over here. Everything here was basic algebra and basically just a little bit of conceptual understanding as to what is representing a length and what is representing a width and the determination of a function, all of which is relatively pre-calculus level. So there it is, half base times height. If anyone ever wants to research this technique some more, you can always go on your website and just look at this Riemann sums, and that's what we're looking here at, Riemann sums. I have posted a couple of videos on these on my other channel, but anyhow, this right here is the technique, Riemann sums. It's a preliminary technique all students learn before getting into integral calculus. But this is all I wanted to present you, how you can come up with the area triangle formula, and this is how it is. Half base times height, half base times height, we're good. Thank you for watching. Have a nice day.